The universe is filled with galaxies, many of them larger, brighter, and more densely packed with stars than the Milky Way. But most are so unimaginably far away that they are too faint to be seen with the naked eye. There is, however, one galaxy visible in the night sky, one that has taught us as much about the universe as it has about itself. The Andromeda Galaxy is a vast, ancient city of stars, more than twice the size of the Milky Way. This story takes us through its ancient origins and into its distant future, using stunning images and detailed scientific discoveries to understand our cosmic neighbor like never before. The Andromeda Galaxy has been known by many names, including the one derived from the constellation it appears in, named after the Phoenician princess Andromeda from Greek mythology. It also goes by NGC 224 and M31 in different astronomical catalogs. Because Andromeda is visible to the naked eye, especially on dark, moonless autumn and winter nights in the northern hemisphere, it was discovered long before we knew other galaxies existed. For centuries, it was mistakenly believed to be a nebula within the Milky Way. The earliest known reference to it dates back to the year 964 AD, when the Persian philosopher al-Sufi described it as a nebulous smear. It was not studied in depth until the invention of the telescope, when Simon Marius rediscovered it in the early 1600s. In 1764, Charles Messier added it as the 31st entry in his catalogue of fuzzy sky objects, unaware that he was listing a galaxy. Later that century, William Herschel observed that the galaxy's center looked slightly redder than its outer regions. Believing he was seeing very fine details, he assumed it was the closest of all the great nebulae and placed it no farther than 18,000 light-years away. In 1845, William Parsons identified spiral structures in other galaxies and added Andromeda to a new category of spiral nebulae, believing them to be unusual clouds within the Milky Way. But not everyone agreed. Some thinkers, including the philosopher Immanuel Kant, suggested these objects might actually be entire, island universes, vast systems of stars similar to the Milky Way, but unimaginably farther away. This idea was too extreme for most astronomers of that time. Everything changed in 1917, when American astronomer Eber Curtis observed a faint nova inside Andromeda. After studying old photographs, he found 11 more novae occurring there, far more than the number found elsewhere in the Milky Way. Even more surprising, these events were about 10 magnitudes fainter than novae seen elsewhere. Curtis realized that the reason they appeared so dim was because Andromeda must be incredibly distant. He revived Kant's idea, suggesting Andromeda was roughly 500,000 light-years away. This bold claim was strongly disputed by another prominent astronomer, Harlow Shapley, who believed the Milky Way was the entire universe and that spiral nebulae were simply objects within it. Their disagreement led to the famous, Great Debate, of 1920 at the Smithsonian Museum of Natural History. Shapley argued for a small universe where the Milky Way was everything. Curtis argued the opposite, using novae and dark dust lanes as evidence that Andromeda was its own galaxy. The debate ended without a winner, and the question remained unresolved until 1924. That year, Edwin Hubble used the Hooker telescope to measure the brightness of Cepheid variable stars inside Andromeda. Since the brightness of Cepheids reveals their distance, Hubble was able to prove beyond any doubt that Andromeda was more than 1,000,000 light-years away. It was a galaxy in its own right. Soon afterward, astronomers realized that all spiral nebulae were galaxies as well, lying tens of millions of light-years away. The enormous, frightening scale of the universe had finally been revealed. Once Andromeda was confirmed as a separate galaxy, our understanding of the universe expanded rapidly. Because it is so close to us, Andromeda gives astronomers a rare chance to study a spiral galaxy from the outside. Since the 1950s, we have created radio maps of it. Today, space telescopes observe it in ultraviolet, infrared, and X-rays. Even though no spacecraft has ever gone to Andromeda, our telescopes, built to see galaxies billions of light-years away, capture incredibly detailed images of it. We have mapped its stars and interior, discovered clouds, clusters, neutron stars, black holes, and many other features similar to those in the Milky Way. Yet everything in Andromeda appears on a larger scale. Andromeda is a barred spiral galaxy, much like the Milky Way, formed around 10 billion years ago. It has grown by colliding with and absorbing other galaxies, and the evidence of these ancient mergers shows in its stretched and distorted structure. The bright, visible part of the galaxy is about 120,000 light-years wide, similar to the Milky Way. But its full structure extends to about 220,000 light-years, making it the largest galaxy in the local group. With over 1 trillion stars, it far surpasses the Milky Way's estimated number. As we imagine traveling toward Andromeda, the first major change would be leaving the Milky Way's plane, where the obscuring glow of our own galaxy fades and more of the universe becomes visible. Beyond the outskirts of the Milky Way lies intergalactic space, one of the emptiest regions in existence. Here, matter becomes incredibly sparse. But this vast emptiness still contains faint traces of stars and planetary systems ejected from galaxies by powerful gravitational interactions. Any rogue planets wandering here would be frozen solid, deprived of all heat and light. Halfway to Andromeda, we would enter its enormous halo, a thin atmosphere of hot plasma extending more than 1 million light-years from the galaxy. Inside this halo orbit Andromeda's satellite galaxies. Andromeda currently has over 20 known companions, with likely more consumed in the past. 3 of these satellites, M32, M110, and the Triangulum Galaxy, are thought to have played major roles in shaping Andromeda's distorted form. M32 is a small elliptical galaxy only 6,500 light-years across, yet it contains a supermassive black hole over 1 million times the mass of the Sun. Scientists believe M32 was once much larger, perhaps even a full spiral galaxy, before Andromeda tore away its outer layers. M110 is a larger elliptical companion, around 17,000 light-years wide. Evidence suggests that Andromeda stripped stars from M110 as well, scattering them into its halo. The Triangulum Galaxy, or M33, is the third largest galaxy in the local group. It may or may not be a true satellite of Andromeda, but the two galaxies have definitely interacted in the past, and will likely meet again in the far future. After millions of light-years of imagined travel, we would finally cross into the outer edge of Andromeda's extended disk and then into its bright, visible spiral structure. Unlike the Milky Way's relatively orderly form, Andromeda's spirals are broken into several uneven segments. These fractures are the result of billions of years of gravitational encounters. Some regions, like NGC 206, are enormous clouds of star formation containing clusters of young blue supergiants. Andromeda contains over 460 globular clusters, more than 3 times as many as the Milky Way. The largest of these, Mayal 2, is so massive and diverse in its stellar population that scientists believe it may be the core of a small galaxy that Andromeda once consumed. Andromeda is likely home to billions of planets, though it is far too distant for us to study individual planetary systems in detail. In 1999, a microlensing event hinted at a possible exoplanet in Andromeda, 6 times the mass of Jupiter. Because microlensing events are rare and unpredictable, this signal may never be observed again, but it still suggests that planets are abundant there, just as in the Milky Way. The galaxy also contains many dead stars, including stellar mass black holes and neutron stars seen through their X-ray emissions. But the true monster lies at the center, Andromeda's supermassive black hole, over 100 million times the mass of the Sun. This is far larger than the Milky Way's central black hole. Andromeda's core is unusual because it appears split into 2 nuclei, one containing the black hole and the other forming a bright cluster orbiting it. Both structures are likely the result of past galactic mergers. Despite the incredible distance, Andromeda is moving toward us. Its slightly blue appearance is caused by blue shift, a Doppler effect indicating that it is approaching the Milky Way at about 110 kilometers per second. Most galaxies are moving away due to the expansion of the universe, but the gravitational pull within the local group is drawing the Milky Way and Andromeda together. In about 2 billion years, Andromeda will begin to grow noticeably in our sky. In 3 billion years, it will dominate the night sky, appearing larger than the Moon. By the time this happens, Earth will likely be uninhabitable due to the Sun's evolution, but the cosmic show will continue for worlds farther out. In 4 billion years, the Milky Way and Andromeda will collide. Though stars are unlikely to physically crash into one another due to the vast distances between them, their gravitational interactions will scatter planetary systems and warp both galaxies into chaotic shapes. The future position of our solar system is uncertain. Simulations suggest it could be thrown outward, pulled inward, or even ejected into intergalactic space. Around 7 billion years from now, the central black holes of both galaxies will merge, releasing powerful gravitational waves. A new galaxy will form, an enormous elliptical galaxy sometimes called Milkometa. This new galaxy will eventually consume its remaining smaller companions. But its long-term future is bleak. Star-forming gas will run out, and as billions of years pass, its stars will age, cool, and die. The expansion of the universe will push other galaxies far beyond visibility, leaving Milkometa alone. Over unimaginably long timescales, its stars will cool to near absolute zero and freeze into dark, solid remnants. Eventually, the galaxy will fade into darkness. Fortunately, humanity exists in the vibrant middle of this cosmic story, far removed from its violent beginnings and its distant, silent end. The tale of Andromeda and the Milky Way is more interconnected than early astronomers could have imagined. And if we have learned this much in just a century, imagine what future generations may one day discover.